Good afternoon, my YouTube viewers. It's Crystal here, and what I'm going to do in this video is what we're going to do is we're going to clean a data set in R. We're going to be using one of R's inbuilt data sets to do it. And so what you have to do is you have to go, every data set has different things wrong with it. So you have to clean the data set on a bespoke basis. So you have to do it on an individual basis. So the data set that we're going to be cleaning is the USArrests data set, which is an inbuilt data set in R. So the first thing that we want to do is we want to call up the data set. So we say data brackets USArrests. But then what I want to do is I want to rename the data set, give it a different name. So we're going to say DF becomes data.frame USArrest. So we're making this data set a data frame. And then we go into data frame, and you can see that it's a data frame with 50 rows of data by 4 columns. So you've got murder, assault, urban pop, and rape. Okay, and then the states are the road names. So that's not very good to have the states as being the row names. So what I'm going to do is I'm going to create a vector and call it index. So index becomes C brackets 1, 2, in row brackets DF. So that means C to 50 because we know that it's 50 rows of data because when we run the data set up, data frame up, it says that it's 50 rows of data. But the computer doesn't know that it's 50 rows of data. So in row is your number of rows, and brackets DF is the number of rows in DF. So our index is a number from 1 to 50 because there's 50 rows in a data frame. And the thing that you need to remember with R, in R, the first number is 1, whereas in Python, the first number is 0. So that's why you always have to keep in mind that R's first number is 1 and Python's first number is 0. Because if you do any work with Python, you're going to get different numbers. So now what we're going to do is we're going to create a column and call it state. So DF$ state becomes row names bracket DF. And then so row names bracket DF is the name of the rows or even the index. So we run up DF, and we can see that we've got this new column of data called state, which is a character. Okay, so now we're going to create another row called index. So DF$ index becomes index, which we have already created. So we're going to set the index as row names. So row names DF becomes DF index. So the column DF index becomes the row names. So DF index becomes null. And so what you're doing is you're removing the index column. And you can see right here that you have your row names as your index, then you've got your murder, assault, urban pop, rape, and then state. So now what we're going to do is strDF. So that's your structure of your data frame. So you can see that it's a data frame. It has 50 observations by 5 variables. So your 5 variables are murder, assault, urban pop, rape, and state. So we do a summary diff. So what this does is this is sort of like the describe function in Python. So every column of data that is numeric gives you a minimum value, a first quarter, a median, a mean, a third quarter, and a max. So the median is the center of the vector. And so since this particular vector has 50 elements in it, how you calculate the median is you take the 2 center elements in the vector, and then after you've taken the 2 center elements in the vector, you add them together and then divide them by 2. And what that is going to do is give you the median. So you can see that the median is different from the mean. So the mean is just you take you sum all of the elements in the vector and you divide that by the number of elements in the vector, and that gives you the mean. So you can see that the median and the mean are different values. And so the median is sensitive to outliers, where I believe the median is sensitive to outliers, but anyway, where the mean isn't. So sometimes it's better to use the median than it is the mean, because the mean just you sum up all of the elements and then you divide it by the number of elements. And so that's why it's always good to select the median and the mean, and then to select what you want to use, the median or the mean, because you can look on this summary. The median and the mean is completely different, especially on the assault. So in the assault, the median is 159 and the mean is 170. So the median takes account of outliers where the mean doesn't necessarily do it. And also with your state is a character, and since the state is a character, you can't really give a summary because it's a character. So now what we're going to do is we're going to do the head. We're going to do the top 6 values in the data frame. So the top 6 values are for the states of Alabama, Alaska, Arizona, Arkansas, California, and Colorado. And so the difference between R and Python is R gives you the top 6 rows, whereas Python gives you the top 5. Although you can insert code in there to change the number of rows that you would like to have if you want them to. And then so next thing we're going to do is we're going to look at the last 6. The last 6 rows of data in the data frame. So the last 6 rows of data are going to be Vermont, Virginia, Washington, West Virginia, Wisconsin, and Wyoming. So then you can look at the top 6 rows of data and the last 6 rows of data. So, and then another thing that we also want to do is we want to see what the column names are. Your column names are murder, assault, urban pop, rape, and state. So that tells you the column names. You can also count the number of unique values in the column of state. And so you got length, brackets, unique, brackets, DF, $ state. So you have 50 unique values. So you have 50 unique values because you have 50 states. And so they have given you data for every state in the United States. And then so now what we want to do is we want to count the null values in each column of data. So null count becomes S apply, brackets DF, comma, function, brackets, call, sum, comma, sapply, brackets, call, comma, is dot null, and you print your null counts, and you have 0 null counts, which is good. And then the last thing that you can do is, because one of the problems with this particular data set is it needed to be scaled. And the reason why it needed to be scaled is because one of the columns of data had a really high number of arrests. I believe it was assault. And then so to scale the data, you say df scale becomes df, num calls becomes sapply, brackets, df, comma, is dot numeric, df scaled, brackets, num calls becomes scale, brackets, df, num calls, and then you have your df scaled. And then so when you scale the data, you see that what happens is all of the data is scaled to give you it's scaled based upon the standard deviation, I believe. But when the data is scaled, then it's easier to make predictions on that data. So that's why you can scale the data if you want to. And I just decided to go ahead and scale the data to show you how to do it. But the thing about these inbuilt data sets is the fact that every data set is unique in R. And so every data set is going to have its own problems. So I just used the USArrests data sets, which has got its own unique set of problems. But if I was to use another data set, such as the air quality, then you would have to do other things to clean it. So that's just letting you know that every data set that you encounter is going to need some kind of data manipulation. And so that's why I decided to go ahead and clean this particular data set because it seemed interesting and to make a video of it. So thank you so much for watching this video. My next video is going to be concerning another topic of data manipulation, and I hope you decide to watch it.